Apportionment in voting is the last unit for our course, um, Mathematics in the Modern World. So these are the learning outcomes. Use mathematical concepts and tools in apportionment in voting. Supported the use of mathematics in various aspects and endeavors in life. So what is apportionment? It is a problem of dividing up a fixed number of things among groups of different sizes. So in politics, this takes the form of allocating a limited number of representative among voters. This problem presumably is older than the United States, but the best known ways to solve it have their origins in the uh, problem of assigning each state an appropriate number of representatives in the new Congress when the country was formed. So states also face their apportionment problems in defining how to draw districts for state representatives. So if you're going to look at the map of the United States, each state has different sizes, different land area, and of course, the number of people and the population in that particular state also would differ. So they're not the same. So that's a problem of the where the apportionment came from, because you cannot just assign one representative in each state, considering that there are some states that has more population than the others. So there are certain rules that we follow. First is the things being divided up cannot exist only in whole numbers. Can exist only in whole numbers. And we must use all the things being divided up, and we cannot add up anymore. And each group must get at least one of the things being divided up. And the number of things assigned to each group should be at least approximately proportional to the population of the group. So these are the general rules for apportionment. So in terms of the apportionment of the United States House of Representatives, these rules imply: first, we can only have whole representatives. Of course, you cannot have a half person, a one-fourth person. So we need to have whole. So that's why we have to be very careful with the use of decimals. We can only use the um, 435 representatives available. This is in the United States. If one gets another representative, another state has to lose one. So this is fixed, the total number of representatives in the United States. Every state gets at least one representative. So when you say at least one, it is possible that other states may have more than one, but you cannot have a zero representative. The number of representatives each state gets should be approximately proportional to the state population. This way, the number of constituents each representative has should be approximately equal. So who is Hamilton? Alexander Hamilton proposed a method that now bears his name. So if you want to propose something, if you want to have to use your name for something, then you propose on something. His method was approved by Congress in 1791, but was vetoed by President Washington. This, by the way, was the very first presidential veto in the United States. It was later adopted in 1852 and used through 1911. He begins by determining to several decimal places how many things each group should get. Since he was interested in the question of congressional representation, we'll use the language of states and representatives. So, first method, first step in the Hamilton's method is to determine how many people each representative should get. So do this by dividing the um, total population of all the states by the total number of representatives. So this answer is called divisor. Um, then uh, divide each state's population by uh, the divisor to determine how many representatives it should have record this answer to several decimal places. This answer is called the quota. Since we can only allocate whole representative, Hamilton resolves the whole number problem as follows. First is cut off all the decimal parts of all the quota. So take out the decimal parts. Don't forget what the decimals were. These are called the lower quotas. Add up the remaining whole numbers. This answer will always be less than or equal to the total number of representatives. And the or equal to part happens only when every specific circumstance that are incredibly unlikely to turn up. Assuming that the total from step 3 was less than the total number of representatives, assign the remaining representatives, one each, to the states whose decimal parts of the quota were the largest until the desired total is reached. That is why you have to take note that the decimal part of each so that you will know which state you need to um, add a representative in case. So we have the problem. There are 3 countries in the state of Delaware: Kent, Newcastle, and Sussex. There are 41 members. So we take note there are 41 members of the House of Representatives of Delaware State. If Delaware decides to divide this delegation into county lines, which is not necessary, but let's pretend they do, let's use the strategy of Hamilton to assign them. The county's population are as follows. So this is based from 2010 census. So we have the country on the first column, and we have the population in the second column. The last part, that is the total of the total of the 3 states population. So first is we have to find the divisor. So the divisor will be the total of all the total population of all the states divided by the 41 members of the representatives. So we get 21,900.82927. So we will be using this divisor in the next step. Bear in mind Bear in mind the divisor is 21,900.82927. So we will be using it in order to find the quota. So using our calculator, this time calculator is very important. 162,310 divided by 21900.82 927, so that will give us the quota, which is 7.41111. So round off up to the 4th decimal place. Next, you will have to divide the second population, which is 538,479 by the divisor. So we have 24.5872, and our last is 197,145 divided by the quota, and that gives us 9.0017. So that is the second step. Our third step would be to remove the decimal portion of the quota. So that is why if we put it in tabular form, we can see our decimal. So this is now our third next column. So we just drop everything. So all the decimal place, 7, 24, and 9. So if we get the total, we add everything, that gives us 41. But there are, 40. This is 40. 7 plus 24 plus 19 is 40. But there are 41 members in the House of Representatives. So what we will be doing, we go back to our quota portion, we analyze, look at the decimal portion, which among the three states has, or three countries has the largest decimal portion, and that is Newcastle. So we are going to add one to Newcastle. So Newcastle will have 25 representatives. Kent County will have 7, and Sussex will have 9. So in total, we have now 41 representatives. Okay, so if you have questions and clarifications with any part of the discussion, drop your questions in the comment section in our private group page. And if you have also some additional things to ask, then feel free to also do the same. Thank you so much and have a good day.